This is Unit 7 of our ASPure notes. We're looking at the binomial expansion, and this is 7.4, the binomial theorem for a positive integer value. A plus b, where n is a positive integer, can be expanded then as follows. So I think you hopefully remember then we kind of started off with a to the power of n, then the powers drop. So say it was 5, would be a to the power of 5, a to the power of 4, a to the power of 3, a to the power of 2. So you can see that that's a to the power of n, then it decreases as the powers of b then increase. The new thing for this bit then is this NC0, NC1, NC2, and this is our NCR. And the way we work this out, this is effectively just a number from Pascal's triangle, but sometimes you end up with like a number like 20, and you don't want to be writing out 20 rows of Pascal's triangle, so we do have other ways of working this out. And so NCR then equals n factorial over r factorial on n minus r factorial, where factorial means multiplying together all the positive integers up to that integer value. So 6 factorial is 6 times 5 times 4 times 3 times 2 times 1. 6 factorial then obviously is 720. If we take a look at this, this is a wee bit of a rigmarole to write out, but you'll kind of hopefully see it and see where it comes from. So it's n is the top line times n minus 1 upon n minus 2 upon n minus 3, and that just kind of keeps going until you hit then n minus r, and then n minus r minus 1, n minus r minus 2, and that keeps all going all the way down to 3 times 2 times 1. That's our top line then of that fraction. R factorial is of course then r upon r minus 1 upon r minus 2 all the way down to 3 times 2 times 1, and then our n minus r, so that's then going to be multiplied by n minus r minus 1, n minus r minus 2 all the way down to 3 times 2 times 1. So a lot of that stuff then kind of cancels out. So I guess if you kind of think about it, we go then, all of that is going to cancel with that. So we're left with n all the way down then to n minus r plus 1, and then we have our r1s here. So that gives us n minus 1, n minus 2, all the way down to n minus r plus 1, which is just a term before that one. That's all of then r minus 1, r minus 2, all the way down then 3 times 2 times 1. Evaluation then of 5(3), which is 5c3, so that then would be 5 factorial all over 3 factorial 5 minus 3 factorial. So what's that going to give us? That's going to give us 5 times 4 times 3 times 2 times 1. That's what 5 factorial means. 3 factorial is 3 times 2 times 1. And then 5 minus 3 factorial then is just going to be 2 times 1. So let's see then kind of how that works out. We can cancel some of these, so the 3 times 2 times 1 there is going to go with the 3 times 2 times 1, and then we've kind of 5 times 4 here, which is 20, 2 times 1 here, so 20 over 2, then that's going to give us 10. We could work it out. 5 factorial on the top is 120, and then divided by 6 times 2, it's going to get us there the same way. Well, maybe not write all of these ones out. We'll see how we get on. 9 factorial, it's going to be 9 factorial all over 5 factorial all over 9 minus 5 factorial. So let's write it out. 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. 5 factorial, 5 times 4 times 3 times 2 times 1, and then 9 minus 5 is 4, so 4 times 3 times 2 times 1. So the 5 times 4 times 3 times 2 times 1 goes with that there. The 4 and the 2 will cancel with the 8. And the 3 then will go, I guess, kind of with half of the 6. So effectively we have 9 times 7 times 2. If you can put that in your calculator, you end up then with 126. Obviously calculator will kind of work it out, but it's just to show you where these things come from. The other way you can do is kind of, you have an NCR button on your calculator, so hopefully you can just about see this here. The NCR button is just above my divide sign. So say I want to type in NC5, I think I go N. So you'll see how it appears there on the screen, NC5, I hit equals and I get 126, which is what we wanted there. So that's where those go. Next video then we'll run through some of the examples where we're kind of using this, but you do need to, I guess, have a bit of a knowledge of this. Sometimes the questions will be asked in the exam where you need to know and understand this, and so I guess it's kind of worth a wee look through. Quite often you can just put the number in your calculator, 9C5 or 5C3, and we can just work those out.